important for us to know the political levers, the tools, and how to do the political work. But we're also ambassadors of this information. So you are going to be expected to know everything about medical cannabis when you're meeting with your elected officials. It's really up to us to become the experts. And the part of becoming the best advocate you can be is to be the best educated advocate. So I'm really excited to have Jahan here.
Thank you all for coming. I hope you enjoyed your lunch. Right now we're going to continue with our program. We're moving up a little bit. We have today Jahan Marcu, who is a cannabinoid researcher from Temple University, who's done some extensive and very exciting research on cannabinoids and their interactions with cancer cells. So without further ado, Jahan Marcu.
Okay, thank you. This is my email, and I also maintain a blog where I rant about science. I'm at Temple right now in the Center for Substance Abuse Research. Next slide, please. So this slide basically sums up what we're going to talk about today, the history of cannabis and the history of the research, and we'll end with talking about some recent findings from this year. So some of the earliest evidence of the existence of marijuana being used by humans is from 8000 BC. There's hemp growth that has been found, and at about 2700 BC is the first documented evidence of medical use in China. And hashish use was probably the most common form of marijuana that was used in ancient times. It's actually thought that when tobacco entered Europe, the reason it spread so quickly was because people had been smoking hash for hundreds of years and had hookahs and all these other things that tobacco fit really well into. But it wasn't until about 1850 that the Western world started incorporating cannabis into its medicine. Then marijuana taxed that, got rid of any sort of research. Then we began to see sort of a resurgence in the interest of cannabis and cannabinoids as a potential therapeutic in the 90s when the CB1 receptor was found, cloned, expressed in a foreign cell. And that was also the year the Research Society, the International Cannabinoid Research Society, was founded, was upon the discovery of the receptor. So cannabinol, isolated THC, became a Schedule III compound in 1999. Sabonex, which is sort of an extract of cannabis, is licensed in Canada in 2005, then again licensed most recently in the UK. Rimonabant is a drug we're going to talk about just a little bit, but it's an anti-obesity drug that blocks the same receptor as THC, so the thought that it could block appetite and had some wildly interesting off-target effects. Including like one case where people who were taking it short-term this drug actually developed full-on MS, and other people had suicidal thoughts, which actually suicidal thoughts is a very common thing among antidepressants. A lot of research has been interested in these natural cannabinoids that are found in the body. Anandamide, which comes from the Sanskrit word for bliss, is sort of the natural THC in our body. It binds with the CB1 receptor. There's also a type 2 receptor that was found. This one is located in the head and may be responsible for all the effects that somebody may be familiar with from THC. CB2 is more of an immune receptor, modulates immune responses. And a lot of research has gotten a lot away from studying animals that are missing cannabinoids. And most recently, in 2005, they discovered other orphan receptors that didn't know what their function was, and then someone threw a cannabinoid on it, and they're like, wow, it activates it. And so there's now about 5 cannabinoid receptors, and it's turning into basically a physiological system, like a full-on physiological system. Next slide, please. So just to wrap up, so for at least 5,000 years, cannabis has been used in the medicine. It's only in the last 70 that it hasn't. The marijuana plant itself contains over 500 compounds, only about 100 of which are cannabinoids. Interestingly, among those, only 1 or 2 or 2.5 really have shown any ability to bind the receptor. So it's kind of interesting why these plants are there. They probably interact with other receptors or maybe other parts of the endocannabinoid system. So, like I said, there are 2 receptors that have been established. And even though this is a naturally occurring compound within our own body, it's made and used all the time, it has never been administered to humans, even though we've known about it for 10 plus years. It's been applied topically as an anti-cancer agent, but it's never been orally consumed by humans. And even though it's been over 40 years since the discovery of THC, we still find new compounds, 40 of which were just discovered in the last 3 or 4 years on the plant. Next slide, please. So where do we get these numbers of cannabinoids? This is an old slide that needs to be updated, but you have THC, which most of us know and love. And we have all these other compounds that are from the plants. CBD has gotten a lot of fame recently, the high CBD strains. There's actually 7 different variations of this compound. And when you talk about isolated studies of these isolated compounds, they're using just one isomer, one version of CBD that's available on the plant, usually the one that's been proven to be the most potent. So you just sort of add these up, the variants within each group, and you get a number 66, and the number that's been counted for a really long time. Next slide, please. So there's different classifications for these compounds. So like we have stuff that comes from the plant, which is thought of as exogenous cannabinoids. So we have plant cannabinoids. We also have synthetic cannabinoids, and we call these ones there's bicyclic and tricyclic synthetic cannabinoids. And then there's the newest member, the amino-alkyl indole group, or the indole variety of compounds, which are a really popular drug of abuse right now. The spice compounds, JWH compounds, are all structurally related to this compound right here. And unfortunately, it didn't show up here, but there's another nitrogen common component of like LSD and psilocybin and those structures. And so it's thought that these indoles might also interact with serotonin receptors and have some off-target effects. This is the structure of that diet drug, rimonabant, that was pulled from the market due to the negative side effects. Next slide, please. Okay, so there's a lot of endocannabinoids. Here are 8 of them. I couldn't fit them all on one slide. There are people out there in the world who do nothing but take brain extracts and do analysis for cannabinoids. I went to a presentation a few weeks ago, and all the lady did was show slides of compounds, new endocannabinoids she had just isolated. We don't know what they do. We don't know if they're degradation products yet. We don't know if they're precursors. We do know how some of them are made, but we don't know how all of them are made yet. It's still a very new research field. Next slide, please. So this is the CD1 receptor. I just want to give you a schematic diagram. It's made up of amino acids, and it kind of goes in and out of the cell membrane. It's a part of a very large family of receptors, known as G protein receptors. Next slide, please. And so this is just to let you guys know that a lot of research has been done focused on the receptor, not so much on smoke, cannabis, and clinical trials, but more on trying to figure out how this receptor works. And what you're staring at is a computer model of a receptor. And remember this slide back a little ways to show different classes of cannabinoids. Why do we have cannabinoids from the plant? THC is the main component. It degrades into CBN. So before THC comes to life, it is this and an enzymatic reaction. CBD is probably the second most abundant compound in the plant. Next slide, please. So effects of THC, we have pain relief, decrease in body temperature, decrease in tension, vasodilation, sedation, catalepsy, appetite stimulation. And this isn't to say you're going to feel all of these all at once. Some of these are dose dependent, some of these occur at certain doses but not at others. The pain phenomenon is really interesting. In healthy subjects, people who don't have chronic pain, THC seems to have a biphasic effect, where at one dose it increases responses to pain, and at one dose it works really well as a painkiller. But it seems to work really well with people who have a chronic pain condition. Next slide, please. So this is just to kind of demystify the plant for you. This is a trichome. Can you hit the next slide, please? So this is an updated version, nice color photo. So this process, starting with these innocent-looking compounds here, eventually gets made into THC and other cannabinoids. And that happens in this tricone, so this waxy protective layer and the oil. This mixture of cannabinoids eventually surfaces and spreads out throughout the plant. And the plant is actually an excellent source to package the cannabinoids. They stay very well preserved inside these waxy trichomes that are protected from light and things like that. Next slide, please. So there are a lot of other constituents of cannabis. You mentioned 500 compounds. We have terpenes, which give cannabis a smell. THC and other cannabinoids don't have a smell. Drug-sniffing dogs are trained to smell rare terpenes on the plant that are very smelly. There's also flavonoids, which give some flavors to cannabis as well. And these smell and taste molecules are thought to contribute to subtle effects of cannabis. Increasing, decreasing blood pressure, increasing, decreasing permeability of the blood-brain barrier. Next slide, please. Here's some structures. So, for instance, myrcene is a common component of mangoes. And one of the things that Rosenthal has written about in his column is that if you want to get, really feel the effects of THC, eat a mango beforehand. It has loads of myrcene in it, and it will help to open up your blood-brain barrier and get even more THC in there. Limonene is another common component, which is widely available. It was actually used in, I think, the 70s and wafted into psychiatric wards to calm patients down. This is the drug-sniffing dog compound. This is HU210. I just do this one up here because it's one of my favorite molecules. It was made in Israel. It's about 1,000 times more potent than THC, and its medical use is for brain damage. So if you're out on a bus in Israel and it blows up, if you sign up for this, you can get an injection of HU210 on the scene from the EMTs, and that will reduce your brain damage, free radical oxygen species. And also, it's been thought to be used for heart attacks. However, it has to be administered within a half hour to an hour after the incident. Next slide, please. And so, we've talked about what the plant's made of. What happens when you smoke it? Obviously, techniques like vaporizing are much more efficient. But how inefficient is smoking? Well, first of all, when you light the joint, you're losing stuff that's being combusted. So you're losing 30 to 50% just from combustion and side-stream smoke. Now you're inhaling whatever didn't get destroyed, but you can only absorb so much through your lungs. And so what is breathed out is a really interesting question, and I don't think it'll ever be funded, but basically you have to have people smoke a measured dose of THC and then collect the smoke and analyze that and see how much THC was left. But that's still so hasn't been done. So the dosing, this is not mine, so I borrow this from someone else. So they approximate that one joint is about equal to 20 milligrams of THC. However, this can vary. I mean, because holding your breath changes the amount of THC you can absorb. These sort of questions haven't even been begun to be investigated. And also, not to mention, there can also be contamination that can affect delivery as well. Next slide, please. And so genotyping cannabis strains, a lot of people like to know that there are different strains out there. They obviously some taste differently, some have different effects. Law enforcement, whether to develop a medicine like Sativex, is 2 cannabis strains that are extracted, and GW Pharmaceutical has done a lot of genotyping. And so what you're looking at here is each one of these vertical lanes is a cannabis sample in a SBU forensic analysis. And each one of these bands is a gene. It's a little blurry, but you can see that there's some differences between these ones and these ones. Those are different plants. So you can tell these apart, and you can't do this over there. In Holland had done a PhD just kind of catalog every cannabis strain that had ever been described, and he reached about 700 or so before they said, okay, you can graduate. So there's at least 700 varieties of cannabis out there. Next slide, please. Recently there was a tomb that was found that contained some really old cannabis. It was about from 2,900 years old. It was found in a tomb. It's been out in the east of China. And they actually were able to detect cannabis. Basically, what they found was a shaman and some cannabis in a bowl here, about 700 grams of dried cannabis. Imagine that was wet cannabis, which is 90% water weight. There'd be a lot more flower tops. It was just flower tops. And over by his head, they actually found a musical instrument, which is kind of interesting. Next slide, please. So, through going through a bunch of red tape, Ethan Russo, a very prominent cannabis scientist, went and analyzed this, and they're using very gloves to protect themselves from the harmful cannabis. And so this is actually a shot of the ancient bud from the tomb. You can see that it still has oil on it. These are seeds, and so it was. It's very hard, it's a great storage material. They were able to detect it. They even genotyped a little bit of it to see if they could relate it to other strains. So interestingly, it was about, cannabis and hops are related to each other. Cannabis separated from hops and became their own separate species about 29 million years ago. Sativas and indicas have recently been shown to separate about 1.9 million years ago and begin their own separate evolution. And this is a sativa plant, and it was in China, so I don't know what that says, but next slide, please. So there's been a lot of ancient cannabis societies, not just the tomb in China societies. And so there's actually recently, it was discovered that the Czech Republic about 29,000 years ago had valleys of hemp growing. The Assyrians left a pharmaceutical legacy, which cannabis is mentioned all over them. Egyptians have the Ebers Papyrus. Indian scripture, the Atharva Veda, has not only indications, but it says that it's a crime to take cannabis away from the sick and the poor. And the Bible has at least a dozen references to cannabis. Most of them are mistranslated by the Greeks. So calamus, or sweet cane, was mistranslated from cannabis or cannabism. But one of my favorite scriptures from the Bible is God directed Moses to make a oil composed of myrrh, sweet cinnamon, cannabism, and cassia. So basically, God asked Moses to make him a tincture. Next slide, please.
Didn't God speak to Moses through a burning bush?
Enough said. Okay, so the Atharva Veda, there's only ancient claims about cannabis as a medicine. We've been mentioning it 5,000 years as medicine. Has there been any evidence to support these claims? And next slide. And like for instance, the Atharva Veda said that cannabis can treat anxiety, insomnia relating from neurological disorders. It also can help with, people had PTSD back in the day. And also addiction treatment, they had libations, they had opium, they had things like that. And so there's been studies that have shown that, whole plant can be used to treat these symptoms, and even treatment of cocaine and alcohol, even in really extreme circumstances. Next slide, please. And so one of the newer avenues of research is phoning dabbling. This is a really sort of an expanding area of research right now. Right now, there's only 4 labs in the world that are doing it, but I'm starting to gain attention because there was these 3 studies which looked at 3 ethnically diverse populations of postmenopausal women, and they found that they had the CD2 receptor mutation. And all of these postmenopausal women with these receptor mutations had developed an early age onset of osteoporosis. And so now people are really interested in looking at how these receptors regulate bone. And so they took mice and they genetically engineered them to not have cannabinoid receptors. And so this is from male mice which are missing cannabinoid receptors. And there are 2 different genetic lineages. And just to kind of give you an idea of how confusing this is, in this mouse line, in this heritage, this genetic lineage, when you knock out the receptor, they have decreased bone and osteoporosis. But in a different strain of mice, these CD1 knockout mice, you actually get increased bone formation, osteopetrosis, which also leads to bitter bones. But the CD2 receptor appears to universally lead to poor bone health when it's knocked out or sort of interrupted. So now we have mice that are missing the CD1 and CD2 receptors, and those guys are really unhealthy. They die early. They have really weird things where they can't satisfy itches. They get scratch themselves a lot, and they are very weak. Next slide, please. So this is an article we published in January 2010, and it was basically we looked at different brain tumor cell lines in petri dishes and wanted to see if we could use cannabinoids to kill them. So we found that we used a combination of two cannabinoids in a certain ratio or amount that you had an enhanced killing effect. Next slide, please. So there's been a lot of evidence about the anti-cancer effect of THC and other cannabinoids, and there was a clinical trial in Spain a few years ago where THC was used to treat glioblastoma, the same sort of brain cancer that killed Senator Kennedy. It's a little bit of a misconception to say that it was a treatment trial. It actually was a safety trial. They had these 7 guys who had reoccurring blastoma, and they wouldn't go away. They had tried just about every sort of chemical or radiation therapy, surgery, and the tumors kept coming back, so the MDs were like, well, let's just give them some THC and see what happens. And the short version is that THC was well tolerated. None of the patients were cured, but it didn't interfere, and it didn't make the tumors worse. And so now they are working on part 2 of the trial, and the THC was administered by injection. There's been lots of look at cancers in mice and other animals, and it's been shown to be effective when it's just direct injection to the site of the tumor. And these compounds are non-toxic. It's not like a chemotherapeutic agent. It just kills anything that comes into its path. Cannabinoids selectively kill cancer cells. And we have a YouTube video where you can watch in real time with 2 side-by-side petri dishes, healthy cells and then tumor cells. And they get the same dose of THC, and the cancer cells die and the healthy brain cells stay alive. So most studies have looked at the single cannabinoid and its anti-cancer effect. We were kind of interested about this question: what are the other indole, bicyclic, what amount of to kill 50% of the cancer cells in the petri dish? And then we get with CBD and THC with CBD. It's really great responses. So I just want to draw your attention to D. And so this is with no drug. It gets 100% cell viability. That means it grows and fills up the petri dish. And this is measured with enzymatic reactions. This isn't just us looking at the petri dish. And so this is with a CBD treatment. It lowers it by about a quarter. With THC alone, it lowers it maybe about 15%. But when you add these two, that do virtually nothing together, they drastically reduce the tumor burden. Next slide, please. So this should be a close-up of a petri dish. And so this is after 3 days. The cells that don't get a drug grow to confluency, fill up the petri dish. They start growing on top of each other. And, after 2 days of treatment with these 2 drugs that individually don't really do anything, you get this drastic reduction in proliferation. Next slide, please. So when we look at this, we want to say, is this necrosis? Is this toxicity? Or is this like pre-programmed cell death or apoptosis, which is what you want to induce in cancer cells, is apoptosis, is that you see that when we use this sort of low-low combination, we get primarily an apoptotic or apoptosis induction, which is great. Next slide, please. And this is just a quick slide. We also, cells go through a growth phase, and so we actually submitted this paper 5 times for review, and each time you submit a paper for scientific publication, it costs between $1 and $3 grand to submit it, and then you have to pay for it to be published. They kept coming back and asking us for more experiments and more experiments. So one of them was to show us what phase of the cell cycle are you inhibiting. So the cells go through different cytosynergy forms like that. So one of them was look at the cell cycle, and the other one was actually measure synergy using statistics. And anything above a 1 is a synergistic increase. Next slide, please. And so when we're looking at cell cycle, you have protein expression. We first stand in this slide to show this reduction of this key protein that tumors hijack. And the combo reduced it, but individual things didn't, but they wanted to also look at 12 hours one day, and then 1 day and a 2-day comparison to see exactly when this reduction was happening. And so we can see that it is happening around within 48 hours, it's inducing its effect. Next slide, please. So we want to figure out how is this effect happening. Was it happening to the CD1 receptor, to the CD2 receptor? So we took rimonabant, the anti-CD1 receptor diet drug, and we took the anti-CD2 receptor drug made by the same company, and we found that the CD2 receptor seemed to be largely responsible for this anti-cancer effect. TCT is vitamin E, and so we also found that the way they were killing the cancer cells was by inducing radical oxygen species in the cancer cells. And we could block those species by supplying a bunch of vitamin E into the petri dish. Next slide, please. And this is more, we had to measure more proteins, because as we said, those proteins are like, well, let's see some more experiments. And so we measured what are called caspases and the T8 gene to show just that this is a real effect, there is a molecular mechanism here. That's a short take-home message. Next slide, please. Okay, so here's the cell cycle slide. We basically found that we were arresting the early and the late growth phase of the cell. And that's just to say that basically we're slowing them down with cannabinoids, inducing radical oxygen species to kill cannabinoids. So you don't just slow down the cell, or intended proliferation, but you're also killing. Next slide, please. And this is an effect on invasion. So glioblastomas are notoriously invasive. They will eat through brain tissue. We can put them on a gel in a petri dish, and they will eat through the gel in 48 hours and go to the bottom of the petri dish. And so we wanted to see if we could inhibit this with cannabinoids. And THC seemed to be able to inhibit invasiveness by about 50%, but there wasn't really that much of an increase in the use of drugs in combination, even in a 1-to-1 ratio. Next slide, please. And so basically our conclusion was that in 2 out of the 3 brain tumor cell lines, aggressive brain cancers we looked at, we saw that cannabinoids were able to synergistically inhibit that in a petri dish, and that this synergistic increase in cell death was due to apoptosis, not to toxicity of these drugs, and that when we use these drugs in combination, we get a targeted approach to a molecular pathway. And next slide, please. And so the future for studies like these is to look at animal models, and maybe clinical trials are using THC to think about incorporating other cannabinoids that share anti THC to make them more effective. And we should also think about genotyping some of these patients, because we can look at their receptors and perhaps predict mutations and pick cannabinoids that will work best for them. Next slide, please. So these are my mentors, Mary Boo at Temple. This is for Sean McAllister in California. These are the grants that funded the cancer research, and NIDA, there's currently an NIDA training grant. And thank you to ASA and Philly Noble. Next slide. So if you have any questions right now, if you have a few minutes, I'd be happy to answer them. And this is my email. Feel free to send me any questions you have. All right, thank you.
Question. You, in one of the slides, talked about a joint and it sort of hinted at a dose. Is there any research or work done like what a dose might be?
Well, you have to start with how much of it is in the plant to begin with.
Well, let's just say like per gram, not like or something like that. Like if you had a patient come in and you made a batch of brownies and you might have used so many grams in that batch, and I might use so many grams in my batch. And
but you need a laboratory to tell you how much THC was in there by weight.
Has that been done, like weight, THC per weight?
Yeah, the government does that all the time when they confiscate cannabis or seize it, they measure the THC. They we don't measure any of the other cannabinoids. But all the marijuana that's distributed through the pharmacy in the Netherlands is tested for 3 or 4 of the main cannabinoids, screened for funguses and bacteria and things like that. So, good.
Back when you had applied the 20 milligrams of THC per joint, was that cannabinoid made with University of Mississippi marijuana, or was that just
Probably something like that, like lower and under 10% THC by weight sort of stuff, like street marijuana, I guess, versus pharmaceutical grade. Yes. Yeah, the sativas and indicas both have cannabinoids in them, but the type that you're going to get is probably different. The type of cannabinoid, so like, you know, yes, exactly. So spice, something I alluded to about the indole derivatives. They're a common component of the spice mixture. These were compounds originally made to do research with because THC is so hard to get for research purposes. And once, as soon as they're synthesized and reported to be a cannabinoid, they usually get scheduled, which means that you can no longer get them through a supplier, you can only get them to the government, and if the government doesn't have a person who can synthesize it, you can't study it. And that's like, we call them asking for drugs, and they're like, oh, we don't know how to make that. Sorry. So you just can't study it. And so one of the concerns with spice bans is that, you know, some guys spend 20 years of his life developing these compounds, and if they start to be banned, then there might be a federal ban, and then they might not see these compounds being used for research anymore because they're so difficult to get a hold of. But spice is essentially a mixture of very potent synthetic cannabinoids that probably have a lot of off-target effects. They share some effects of THC, but then there's been a lot of other things that have not, that don't really seem to make sense, such as decreased breathing rate and compression of breathing has been reported with high doses of spice, which is something that no cannabinoid has ever been shown to do. So there might be other things in these spice mixtures. It's just that people have only been able to find cannabinoids in them.
You mentioned that it was very difficult to find the liability in the research that you said failed the most. Remember you put up the slide? I'd be more than happy to allow you to contact me by the
If anyone wants to like give us some money to fund that study,
elements to certain strains, the scientific community putting together a solid science-based list that
yeah, it's much more limited than you would think. Like GW Pharmaceuticals has a genetic library of strains they've been doing for years, and they've found that they think works best for MS, and what they think works best for pain. And but it hasn't been done to the point where they can say blood professional good for MS, but they can look at it as a genotype expression of the cannabinoids to make it that way. And they literally combine some types of weed to make their preparation. So there is some validity to that, the strain-specific consideration.
is that published? Is that available? Sort of underground?
It is available. I mean, they haven't published most of their data about that. The study was at the conference that was just at, the representative Jeffrey Guy from the other pharmaceuticals was there, and he put up a slide, but it was all unpublished stuff, like the amount of each cannabinoid in their mixture, which they don't even tell you what terpenes are in their mixture. But there is certainly, certain individual plants can see effects and inhibit side effects as well. So they keep everything from terpenes to a very small amount.
The question is directly related to the last question. The CD1 and CD2 receptors, are they related to indica or sativa in any way? And is indica or sativa one of them, which is used more for medical marijuana?
It's
difficult to say. So sativa is a good question. Most strains in Northern California are largely sativa. It's not all sativa. Skunk number 1 was found every year in drug busts. The strain that was made is proliferated. Indicas are starting to be seen. The CB1 and CB2 receptors are affected by THC, and that is found in both sativas and indicas. Sativas and indicas differ in many of the minor components of the other cannabis, so they both have THC. Sativas generally have a lot more.
Is there any research done or is there any known how much THC is in marijuana?
Not the THC, but like people develop kind of like people allergic to flowers and the pollen and things like that. Yeah, there's been I think one documented case of someone having an allergic reaction to one. Yes. Afghanistan. So from Afghanistan, Kush Mountain region is another variety. Luteral has been told it grows like a shrub. Ed Rosenthal described the drug once at a talk as, smoking Luteral himself. He described it as somewhere between a headache and not being high.
The United States, everywhere most